Hello, everyone. Today we are diving into a new topic, regression analysis. This continues the journey through the quantitative method of budgeting. Let's quick recap what we've done so far. Okay. We started with ILO method, completed. We moved to correlation analysis, completed. Now it's time to move forward with regression analysis. Let's get started. Okay, so now it's time to start a new topic, regression analysis. So what is regression analysis? Remember when we started our high-low method, we use high-low to separate fixed costs from variable costs, right? Now, regression analysis is a modern technique, right? It's an alternative technique. It's a forecasting tool, okay? Developed as an alternative. It's a forecasting tool developed as an alternative to the traditional high-low method. We refer to high-low method as the traditional high-low method because high-low method is not much accurate. Why? We have several information. We are only selecting two items to determine our variable cost and our fixed cost using the high-low. With regression analysis, it's a forecasting tool used to calculate our fixed and variable cost as well. But in this time, we're using all variables. Okay? All variables. So what is the formula for? Remember, for our high-low method, we say total cost is equals to fixed cost plus variable cost. Remember this? In our high-low method, total cost equals to fixed cost plus variable cost per unit. Multiply this now by number of units. This will give us the variable cost in total. This will give us the variable cost in total variable cost. So this is how we used to get our total cost using the high-low method, fixed cost plus variable cost multiplied by number of units. This is how we used to get our variable cost and total cost in high-low method. But with regression analysis, we don't use this variable cost, total cost, fixed cost, or variable cost. We say the formula is y is equals to a plus bx. This is the formula to calculate fixed cost and variable cost using regression analysis. If you notice, there is a similarity between this one, this, and this. Consider this number of units to be x, so it's become Vx. You know, there is that similarity. Okay? So this is the formula we'll be using for regression analysis. All right? So now, how do we calculate A and how do we calculate B from a data? So if we want to calculate A, as a formula for A, we say is sum of y divided by n. We know what n is now. N from the high-low method, the same way we get n from a high-low method. Sorry, from correlation, is the same way we get n for regression analysis. Minus b, okay, sum of x divided by n. This is b multiplied by sum of x divided by n. This is how we get our A. Now, sum of y we can get from data, n we can get n from the data, sum of x we can get from the data, of course, n from the data. Okay? So now, how do we get B? How do we get our B? B is n, which is the same n goes for number, sum of xy, total of x and y, we multiply x and y values, we add them, that will give us sum of xy, okay, minus sum of x, sum of y, okay, all this divide, and sum of x square minus sum of x all square. So this is how we get the B. Let's go over. Regression. Let's take our time. It's very important. This is an important topic for management accounting, performance management to be specified. Regression analysis, y equals to a plus bx. Okay, we see the similarities, the difference between the high-low method and the regression analysis. And how do we get A? A is sum of x divided by n minus b into sum of x divided by n. And for B, sum of x, y minus sum of x multiplied by sum of y, all is divided by sum of x square minus sum of x whole square. We can do this with a question. We'll see how we apply the formula. Okay. So when we do this, when we do this, we'll get variable cost per unit. When we do this, we'll get variable cost per unit. Like we used to do for high-low method, you have the variable cost per unit and you multiply a number of units to get the variable cost in total. Remember high-low method? Same for this. When we do all of this, we have the variable cost per unit. Okay, let's go. So now with this understanding, remember we said regression analysis is a forecasting technique developed as an alternative to traditional high-low method. That's the definition. It's a forecasting technique. So now, having done that, let's see how we can do with this question. We have a question here with 6 requirements. We have month, unit produce, and total cost. January to May, and required 1. Today, I'm going to do revision as a form of recap for those who are not in class for the high-low method. Okay, find the variable cost per unit and fixed cost under the high-low method. That's the first requirement. So if I'm going to do this, I'm going to be fast with this one because we've done several questions on high-low method. So I'm going to look at high activity. I'm looking at low activity. Okay, that's my step 1. Remember, step 1. So my high activity unit I will look for, our highest is 24. Right? So I will say 24,000. Okay. And the low activity is 16. I will say 16,000. And 24, we have 70,000. This is the total cost, 70,000. And for 16, we have, for 24, we have 90,000. And for 16, we have 70,000. Okay, sorry. And do this 2 will give us here 20,000, deduct, and this will give me how much? Calculator? 8,000. So I finished my second step. First step, identify the activity, the high and low. Second step, get the difference. Okay, now I finished that. Now my variable cost per unit. My variable cost per unit will equals to 20,000 divided by 8. This will give me how much? This will give me 2.5, yeah, per unit. This will give me 2.5 per unit. This is my variable cost per unit. Okay. Now we are asked to find the variable cost per unit and fixed cost under high-low method. I need to get the fixed cost. For me to have my fixed cost now, since I've got my variable cost per unit, so I need to get, we are still on requirement 1. The variable cost now in total is equals to variable cost per unit multiplied by number of units. My variable cost per unit here is 2.5 multiplied number of units. Which unit do I want to use? High or low? Whichever. I'll use. Which one do you want us to use? High or low? Anyone you choose is good for you. So let's go with low, which is 16,000 units here. 16,000. So this will equal to what? Take my card. Yeah. 2.5 multiplied by 16,000. This will give me 40,000. This is my variable cost in total. Remember to this formula. Come back to this formula. We are looking for fixed cost. We are looking now for fixed cost. We are looking for fixed cost. But we have total cost equals to fixed cost plus variable cost. Now we have our total variable cost to be how much? 40,000. And we have our total cost in the question. How do we get our total cost? Because we use the low activity of 16,000, so automatically our total cost becomes 70,000. Okay, so now I'll bring my total cost, which is 70,000. And my variable cost, total variable cost, is 40,000. So therefore, my fixed cost is equals to 30,000. If you use the high activity, you're supposed to arrive at the same 30,000. So you can try that and let me see your answer for the using the high activity. Okay. So requirement 1 is done. Now move to requirement 2. Find total cost in June. Total cost in June if 90,000 units are made using high-low method. Okay, this is now for requirement 2. Total cost in June if, so total cost in June if 19,000, I think 19,000, let me confirm. Yes, 19,000 units are made. Now, this comes us to the definition of fixed cost and variable cost. Irrespective of the number of units made, fixed cost in total remain constant. Remember? Fixed cost in total remain constant, irrespective of how many number of units are made. Doesn't matter. So automatically, our fixed cost, which we already have to be 30,000, remain constant, irrespective of the number of units made. Doesn't matter. So now, our variable cost, remember, we have variable cost to be 2.5 already calculated. Already calculated, 2.5. Now, how many units? 19,000 units. 2.5 at 19,000. 47,500. This will give us 47,500. So remember the definition of variable cost. Variable cost change in line with the level of activity. When the level of activities increases, variable cost increases. When the level of activity decreases, variable cost decreases. Don't forget, remember. So now, this will give us 77,500. This is our answer for the total cost in June. Total cost in June will be in June will be 77,500. This is our total cost in June. This answer question 2. Any trouble? You can always pause the video, go over, pause the video, go over. Okay. Question 3. Find the variable cost per unit and fixed cost under regression. Now, remember, I told you regression is a forecasting technique developed as an alternative to high-low method. Look what happened. In our high-low method, we only use 24,000 and 16,000 in all of this data to calculate our fixed and variable cost. With regression, say no, let's use all the information. All the information. So first of all, what's our N? I told you our N. N, we can count 1, 2, 3, 4, 5. So our N in this question is 5. Okay, so now we are using the data now to do regression analysis. So 3, using regression method. Using regression method. And we know A. Let's go to the formula for regression method. Look at the formula. A is equals to AY divided by N minus B XY divided by N. And B is the, so logically, we need to get B first. We'll look for B first before we can get A. Okay, regression, we don't need Y square. But for that requirement, you will see they ask us in requirement 5, assess the strength of the relation between unit. This is correlation. The strength of the, we want to know the correlation. What's the correlation between them? If they have strong correlation, partial correlation, or weak correlation. So automatically, for us to get the strength, then we need y value. So we don't want to wait until we come to that place. So now what I will do, I will just do my y square. Remember the formula for correlation. These are my values. So my x, for calculation purposes, I will skip the 3 zeros for now. I will skip all 3 zeros. Let's work in 1,000. So I will have 20, 16, 24, 22, 18. My x value. I have 20, 16, 24, 22, and I have 18. These are my values for x. My values for y, I have 82, 70, 90, 85, and 73. My value for y. Okay. Okay. 82, 70, 90, and 85, and 73. So when I total this, will give me 20 plus 16 plus 24 plus 22 plus 18. This will give me 100. So this is my sum of, sorry. This is my, let me use another color. This is my sum of x. Sum of x. Okay. So when I total all of these, this will give me my sum of y. What is that? 82 plus 70 plus 90 plus 85 plus 73 give me 400. Sum of y. Now I need xy. Xy will equals 20 more. You don't need to do it here. You know, 20 multiplied by 82. 16 multiplied by 70. 24 multiplied by 90. So this will give me my xy. This will give me my xy. And when I total that one, I will have my sum of xy. Are we together? Okay, let's go. So what do I have here? 1640 and 1120. Okay. What do I have here? 2160. Okay. 1870 and 13 14. 15, 14. Okay. And I total this one will give me my sum of xy, which is equals 8104. 8104. Okay, we go. We are close already. We're very close now. And I need x square. X square is 20 square. Okay, 20 square is giving 400. I'm using my x values now for x square. All my x values for x square. When I need y square, I will need all my y values. So for now, I don't need this multiplication. Just for teaching purpose, you don't need it. Okay. And 16 square, 256. And 24 square, 576. Okay, 484, 324. This will give me my sum of x square, which is almost 2040. And finally, y square. We don't need y square for now for the regression analysis, but we need y square for the strength of the relation. So let's just have it now. Okay. Y square is 82 square, 70 square, 90 square, 85 square, and 73 square. This will give me 6724 for the first one. 6724. Second one, 4900. Third one, it's 100. And the fourth one, 7225. And the last one, which is 73 square, 5329. And this will give me 3,000. No, 32,000, sorry. 32,000. This will give me 32,278. 278. This is my sum of y square. Okay. Now we'll get the figures for x, y, x square, y square, and so. So now let's go. We need to remember we calculate b first before a. Why? Because we need b in a calculation. What is b? B, we say the formula is n. The same formula, I'll bring it down. Sum of x, y, all this divide by, okay, minus sum of x, sum of y, okay, all this divide by n, sum of x square minus sum of x all square. So now, if I want to do my b, what is n? N, it says 5. Remember, n is 5. Come back to the question, we count. Come here, we'll count 1, 2, 3, 4, 5. N is 5. Okay, now we go to the table and formula. We said n is 5, confirm. Now we need sum of xy. Sum of xy. Look at it here, sum of xy, 8104. So it's 8104 close minus sum of x. Sum of x is 100. Sum of y is 400. So it's 100 multiplied by 400. Here's the formula. And now we go. And denominator, n again, we say n is 5. Sum of x square. Now, sum of 100 square, x square. Sum of x square. What? Look, we have x square here. Sum of x square is how much? 2040. See that? Sum of x square is 2040. So it's 2040. Sum of x square. And minus sum of x all square. Sum of x is how much? 100. So it means 100 square. From this point, it's easy. We can just go. From this point, it's easy. So if we want to substitute further, we go 5 multiplied by 8104. This will give me 40520 minus 40,000. 400 times 40, go. And 5 times all of these will give me 2,200 minus 10,000. 400 square. So B is equals to numerator 520 divided by denominator 200. Then this will be, let me put this in a change color. This will be 2.6 per unit. So we got our B. 2.6 per unit. We got our B. Any trouble? Okay, so now we need A. We need A. How do we get A? Don't forget the formula for A. Okay? The formula for A. We learned the formula for A recently. In that formula, why we delayed even because I said we need to calculate B first before we can get A. Okay? The formula for A we said is sum of y. Remember? Divided by n minus b. Sum of x divided by n. That is b multiplied by sum of x. Okay. So what's sum of y? Sum of y. So the table sum of y is 400. So therefore, this is 400 divided by n is what? 5. What is b? We have b now to be 2.6 from this answer. We have b to be 2.6. Okay, multiply. What is sum of x? Sum of x, 100. So sum of x is 100. Sorry. Sum of x is 100 divided by n is 5. So therefore, this will give me 400 upon 5. This will give me 80. 80 minus. And all of that 100 divided by 5 multiplied by 2.6 will give me 52. 52. Okay? Will give me 52. Equals to what? A is equals to 28. A is equals to 28. So we've completed requirement 3. A is equals to 28. So let's go to requirement 4. 4 says, let's go to the question. You can find total cost in June. Requirement 4. 4 says find total cost in June if 17,000 units are made using regression method. So we are asked to find the total cost in June if 7,000 units are made using regression. Remember the formula for regression analysis. Say y is equals to a plus what? bx. In this question, x is equals to 17,000. Just like the high-low method, variable cost per unit multiplied by number of units. Number of units is 17,000. X is equals to 17,000. So therefore, what is A? We have our A already to be how much? 28. Remember, we have A to be 28. Plus, what is B? We have B to be 2.6. X is 17,000. But remember, we have been working with 1,000. Skip 3 zeros. Don't forget. Consistency. We have been keeping 3 zeros. We're working in 1,000 from the table. Remember? So by default, A should have been 28,000. Okay. So now, what do we have here? 17. BX. B is 2.6 and X is what? 17,000. So we have 17. Okay. So therefore, Y is equals to what? 72.2. Remember, we are working in 1,000, or we can say it's 72,200. If you work full without the 1,000, you will get 72,700. But because we skip 3 zeros while working, so our answer is 72.2. So this is what we call regression analysis. This is how we solve regression analysis. All right. Now we move to the next one. This is going to be long a little bit. Anyway, first question. The next one, we are asked to assess the strength of the relation. Can this one be assignment since we just completed correlation? For your feedback for the correlation. Okay, if you have any trouble,